Okay, so in this video we're going to discuss a circular motion. Then I'll end it by giving a review on linear momentum regarding the question that came in the previous assessment that you had. Yeah, so to begin with, I'll be using these notes. So this is for you, Madali, so for you to just revise, to be able to go through the concept. Though there was no question on circular motion I couldn't find any in the paper that you recently wrote. Yeah, but I'll just give you a background and the necessary things that you need on circular motion. Yeah, so to begin with, we are saying circular motion is just a replica of everything that you learned in linear motion. So in linear motion, you learned the following equations. You know there's acceleration, which is just final velocity, initial velocity over time. You learn to say there is final velocity is equal to initial velocity plus acceleration times time. There was a distance. You said S or X is equal to ut plus half at squared. So you had all those equations in linear and in a straight line form. So we're saying every quantity that was discussed in linear has a twin in circular motion. Yeah, so circular motion, we're going to be alternating. So someone who says circular, angular, or rotational motion, they mean the same thing, right? That's what we have. And under circular motion, acceleration is going to be represented by alpha. Then velocity, we have final velocity is going to be represented by omega final. And initial velocity is going to be represented by omega initial. Then your distance is going to be represented by theta. And the units here for angular acceleration is simply radians per second squared. Then for velocity is simply going to be radians per second, or sometimes it can be in revolutions per minute. Same applies here. This is just radians per second, or it can be in RPM. And then this can either be in radians or rather in revolutions. So we need to know to say one revolution is just equal to a 360, that's a 360 radians, or rather we're just saying one, this is degrees, one revolution is the same as 2 pi radians. So this is in degrees. We can change it to radians, which is just going to be that. So this is what we know. This is what we have. So all the equations, so here in your notes, they simply give you all they should give us all the expressions. So here, in this here, they're just trying to explain that anything that moves in a circular motion, at some point it would want to move in a linear form. Yeah, so this is the conversion we need, and we're just going to have everything replaced. So everything that you learned, like acceleration to be v, then u over t. Here we're going to say alpha is equal to omega final minus all the equations. The only thing that is consistent between linear and circular motion is time, but everything else is, or rather is going to be represented by different quantities. So just an addition to what you already have on the formulas, we also have period. Period is simply the time taken over the number of revolutions. So if you want to get the period in one revolution, you can just do this. So rather we're just saying frequency is just equal to 1 over the period that you have. Yeah, so that's 1 over the period, that's frequency. Yeah, so you have these simple equations that you have. Then in cases where they give you a straight line expression, like those expressions you were looking at under kinematics, if I give you alpha, I hope you remember those equations where you were differentiating, let's say t3 plus, let's say 10t, you know to say if this is a displacement equation, you can always differentiate it to get the velocity one, and also you differentiate it again to get the acceleration equation, right? The same would apply, except that we would always have to convert every quantity that is in a linear. We have to take it to circular if we are talking about something moving in a circular path. So the relationship between linear motion and circular motion is only by the following 3 equations. So the first one is that linear acceleration is equal to angular acceleration times r. Then the second one, we're just saying linear velocity, whether final or initial, is equal to the angular one, the circular one, times the radius. Then The third one is that linear distance or displacement is equal to the angular one times the what? Times the radius. So these are the three equations that connect the linear motion and the circular motion. These are important. Then apart from this, we can talk about how the whole idea came about. Why is there a relation between the linear motion, something moving in a straight line, and something moving in a what? In a circular path. So this is where the centripetal thing came in. So these guys came up with an understanding to say, provided something is moving in a circular path, let's say you have this, it has a tendency of wanting to decelerate towards the center. So it wants to move towards the center. We have our radius there. So that acceleration that causes it to want to move towards the center is what you call centripetal acceleration, denoted by AC. This is just V squared then over R. That's the formula for centripetal acceleration. Then if there's acceleration, meaning there should be force, and we know to say force is equal to mass and acceleration. So if you have centripetal acceleration, meaning you also have centripetal force. Now remember, we're from saying V is the same as omega R. So where there's V here, we can replace with omega and R. We put a square. This is just that, meaning this is omega squared and R squared, then R. We can cancel the R, cancel one R there, meaning centripetal acceleration can also be written like this. This is another form. So because we have centripetal acceleration, it simply means we have centripetal force. That's the force that is going to keep a particular object moving in a circular path without actually coming towards the center. You have so many applications to this, like in the centrifuge. Yeah, so those are numerous applications that you can have. So centripetal acceleration is there. Then we have centripetal force, which is just going to be an inversion, because this is just going to be M. We already talked about this. That's V squared that. Or sometimes F is equal to MA. We can just say acceleration is omega squared and R. So either, depending on the type of velocity that you are given. Yeah, so that's what you have. That's the first thing you need to know. Then here we're just saying, okay, so this is we have tangential acceleration. So this part here just explains the fact that acceleration can either be positive or negative. Why? Because acceleration is a vector. That's what we have. And because it's a vector, we can always be getting the net acceleration by just using this fact to say the net acceleration is equal to the tangential acceleration squared and the centripetal acceleration squared. This squared is simply going to give us the overall net acceleration. Yeah, so we need to keep this in mind. So here is what I was explaining. Every equation that you discussed in linear has a twin in angular, or rather in circular motion. So hope this is okay. All the equations, this is here, this V with a bar is average velocity. So distance is just average velocity than that. And so all the expressions have twins. So here they're saying what I'm from giving you. This is, I talked about the relations. This is what you have. So you have the one for velocity, for acceleration. The other application for learning circular motion or rotational motion is simply the law of gravitation, Newton's universal law of gravitation, which is simply given by this formula here. So Newton came up with a rule, or rather a law, that says whenever two objects are close to each other like this, and this is the distance between them, from the center of this guy to the center of the other guy, this is capital letter R. If you know the distance between them, we can always find the force that is causing them to be attracted to each other. Whenever you bring two close objects close to each other, there's always going to be some force of attraction between them. And to know that force, this is simply the formula that we're going to use, the gravitational constant, capital letter G, which is always given, and the mass of the first object times the mass of the second object over the distance between them squared. That's how we get the gravitational force between two particular objects. Now, this is important because it's going to be used to actually calculate the mass of something. Yeah, so if you're looking for, this is how they're just explaining how they got gravity. This is how they got the whole idea of having gravity G to be 9.8. It's not really necessary for you to know. Yeah, so this, I was saying this is important because it can help us calculate the mass of a missing object or the velocity with which planets move about. Yeah, so we are simply going to be relating the gravitational force with centripetal force. So if two objects are put close to each other, we'll keep one to be constant. So we'll make this guy here to be at rest. So this is like going to be our origin, meaning this is the only guy that's moving. So we're just saying this is moving in a circular path. Let's call this B. So B is moving in a circular path around A, which is at rest. So it's like we're just having B moving, and it's supposed to feel some force, right? The force that B is feeling as if it wants to come towards A, that's simply the centripetal force, right? But the force of attraction initially between A and B is also G, keeping them apart. That's the gravitational force. So those two forces are supposed to be the same. The force Fg is trying to pull this side, then centripetal force is simply keeping it at this particular distance constantly as it is moving around. So we can equate the two equations and then solve for the missing quantity. So this is where the V is coming from. The radius, the R will cancel, because the distance between them is going to be like the distance from where this object is to the center of this whole circle pathway that it's making. So this is the relation that we're making, and if you pay attention to it, we're just saying since centripetal force is equal to the gravitational force, this is just for one object, mass, let's say the A, right? I'll say for object A, then no, B, this is B, it's the one that's moving, right? So we put B, the guy that's moving, because it's the one that has velocity. Then here we're having G, the mass of A and the mass of B, then over the R squared. Then here we can cancel one R, I mean this MB and MB will go, one R goes with this R, meaning V squared is equal to G, MA and R. So you can just divide square root both sides. That's how they got this V to be that. And they just differentiated the masses by one having a capital letter, then the other one having a small letter. That's the basic application of all this is just the application, then time period. This is another thing that they're adding to just talk about frequency later on. So this is always given. If they need, this is the period, then you know frequency is 1 over there, the period that you get. So naturally, this is what you basically have on circular motion. Now, if we look at these are examples, right? If we look at these examples, these are practice questions. They're saying a pulley having a 5 centimeter radius is turning 30 revolutions per second about a central axis. It is slowed down uniformly too. So it moves from 30 to this in 2 seconds. Calculate the angular acceleration of the pulley. So we have to convert each of these revolutions per second into radians per second. So if you want to do that, we're just saying 30 revolutions per second. I'm going to multiply this by 1 revolution is equal to 2 pi radians. So meaning the revolution cancels. This is going to be a 60 pi radians. Since I don't have a calculator, I'll just leave the pi to be there. So this will be 60 pi radians per second. Then this here is going to be a 40 pi radians per second. We're looking for centripetal acceleration, which is alpha. Alpha is omega initial, and then omega final minus that. This is just a 40 pi radians per second minus a 61 divided by 2 seconds. This is supposed to be negative 20. That's going to be a negative 10 pi radians per second squared. That is going to be your angular acceleration. You can multiply 10 by pi. Yeah. So make sure your calculator is in radians as you are punching this. Then here they're saying the angle through which it turns this time. So the angle is just theta, right? It's like they're asking for the angular distance That's your theta. So here, what's the angle? So we can just go straight forward here and just get the angle, meaning what's the theta? This is going to be initial, then time, half, then we have alpha, t squared. We use this because that's what gives us the distance, that's the angle. The initial is simply 60 pi radians, the time is 2 seconds, half the acceleration is -10 pi, the time is 2 squared. Then you punch this, then you get your answer here. Then they are saying the length of the belt as it bends in the same time. So the length, we know to say S is equal to this, the length is S, the radius is simply 5. So if it's 5 centimeters, we can convert it, that's going to be 0.05 meters. So 0.05 times whatsoever angle you get there. This will give you the length, and the length has to be in meters. So hope this is okay, hope this makes sense. Then the next one here, they are saying a race car travels. So I'm just going to give you a hint here to shorten the video. A race car travels around the circle with a radius of 200 meters. It does a complete lap every 25 seconds. So meaning it completes one revolution in what? In 25 seconds. Meaning this is the same as what? You can divide this. So I'll just use this calculator here. Yeah, so we're going to have 1 divided by we're saying 1 divided by 25 to get the revolutions. That's 0.04 revolutions per second. All right, that's the velocity. You can convert this to radians per second. This is going to be multiplying 2 pi, that's going to be 0.08. Then pi, that's radians per second, that's what you have. So I don't have a calculator for pi. Then they're saying, what's the centripetal acceleration? Centripetal acceleration is the same as V. We don't have V, right? We have omega. So we use that other version of centripetal acceleration, which is omega squared times r. The omega squared is this guy, 0.08 pi to the power 2, multiplying the radius, which is a 200. Then this gives you what? Your centripetal acceleration. Yeah, so you can just try to attempt. These all questions are basically what I've just discussed. So this, you can just try this, then you can give me a response. Try to WhatsApp me on this number for your solution, so that I just try to go through what you're going to get. So this wraps up circular motion. Yeah, this is circular motion up to this point.